In this video, we will assign the defined multiplets to protons in the structure. This step requires a structure to be attached to the record. Begin by launching the corresponding dialog under NMR tools. I'm clicking Assign Structure. In this dialog, we will assign the multiplets to protons. It doesn't matter if you begin with the structure or the rows in the table. Moreover, you'll notice that each of the protons in this structure has an atom ID. You can also give the heteroatoms atom IDs. Go to View and click on Assign Atom IDs to all atoms. In this case, now all heteroatoms have an ID. You can use this for unique cross-couplings, such as coupling with phosphorus. I will turn that back off because we don't have any heteroatom cross-coupling. There is also a setting here to group atom IDs for equivalent atoms. Now in this case, I don't have a symmetrical structure, but if I did, this would allow me to toggle the symmetry on and off. To assign a proton, click on its row either in the table or on the structure and choose Assign Atoms. I will repeat for proton number 2. In this case, I will show that you can actually use a drop-down menu by clicking on the cell and selecting the corresponding checkbox to assign the proton. You'll notice that the number of hydrogens column automatically populates to the number of hydrogens in the structure. I will repeat for the proton at position number 3. While I'm doing this, there is also a second table populating. This allows me to assign the cross-coupling. For example, proton at atom ID number 3 is cross-coupled with position 2. So in the lower table, I can choose atom ID number 2 to suggest that it's cross-coupled to give the displayed J value. I'll repeat this for the protons at position 2, which are cross-coupled with the protons at position 3. There is no possibility to use the cross-coupling table for the atom at position 1 because there is no J value to assign. I will repeat for the remaining protons in the structure. You'll notice that when I assign a proton with a more complicated splitting pattern, I now have 2 J values to assign. For proton 6, the smaller J value belongs to the proton further away, and the larger to that which is closer. There's a similar result for proton number 4. I can also use the drop-down menu to select multiple boxes. In this case, this multiplet represents the overlap of 2 separate protons. And thus, I choose 5 and 7, and my number of hydrogens equals 2. Because there is no coupling constant here, once again, there are no protons to assign in the lower table. Now, all of my protons have been assigned, and I can save the changes.